All right, folks, today we're going to talk about the law of conservation of mass and balancing equations. The law of conservation of mass says that in ordinary chemical and physical changes, mass is not created, nor is it destroyed. In other words, the mass before a change must be equal to the mass after the change. Some examples that show the law of conservation of mass. For a physical change, if you took a piece of wood and you measured it before, you cut it in half and measured the two pieces plus any sawdust you happen to create in the process all together, the mass before you cut it and the mass after you cut it should be exactly the same. Also for chemical changes, if you mix two liquids together that participate in a chemical change, if you measured the mass of both of the liquids beforehand, mix them together, then measure the mass of both the liquids afterwards, it should be exactly the same. Chemical changes, or chemical reactions, is another phrase for them. They're nothing more than a rearrangement of atoms. Now, what happens is the molecules that you start with, they split apart, they break apart into their separate atoms, and those atoms get together in a different combination, creating a new substance, something that wasn't there before, a different molecule, but made up of the same stuff. So we use chemical formulas to describe molecules, but the interaction between molecules, those chemical reactions, we have to use something called a chemical equation, where it tells us we start with this, and we end up with this. So in a chemical equation, we have those chemical formulas that we're used to. We also have coefficients, which come before the chemical formulas, and that tells us how many molecules are required for that reaction. We have the subscripts, which are a part of the chemical formula, and they tell us how many atoms of each element are in that molecule. And we have in the equation, on the left side of the arrow, we have reactants. The right side, we call those products. We call these reactants the left side because that's what we start with. That's what we react together for the chemical reaction. On the right side, the things that are produced or they're made, and that's what we end up with. There are 6 major steps to balancing a chemical equation. The first step is to write down each different element that you have in the whole equation underneath that middle arrow, and you put those down in a column, one right on top of the other. The second step is to count up how many atoms of each of those elements you have on the reactant side, or the left side. Third step is to do the same thing, but for the product side, or the right side. At this point, you should see whether your equation is balanced or not. If all of the numbers are the same for each element, then you're good to go. If they're not, you need to add molecules on the side that is lacking atoms for a particular element. So to add molecules, you just change the coefficients. If there's not a coefficient there, we assume it's 1. But if you want another molecule, then you change that 1 to 2. Every time you change a coefficient, you have to stop and recount the number of atoms that you have. When you do that, you should see eventually that all of your atoms will line up perfectly. You'll have the same number of each element on both sides. And then at that point, you have a fully balanced equation. You can never, ever, 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 ever change these subscripts to change the number of atoms that you have, because when you change the subscripts, you're changing what the chemical reaction is. You're changing the identity of those molecules. So you can't change the subscripts, you can only change the coefficients. It's important to get a balanced chemical equation because it shows us the law of conservation of mass. In order to follow that law, we have to end up with just as many atoms as we started with. We cannot create or destroy. In other words, we can't gain or lose any atoms during that chemical change, so our equations have to be balanced. All right, so let's do a practice problem. This one is H2 plus O2 gives us H2O. And you'll see here, right underneath the arrow is where we want to write down the different elements we have. You see we have H, and we have O, and we have the same thing on the right side. And when you're counting up the number of atoms you have, you can see there's an H2, so there's 2 H's. There's an O2, so there's 2 O's. And on the right, we have an H2O, which is 2 H's and 1 O. You'll notice at this point our H's are balanced, but our O's are not. So you're going to want to change the number of O's on the right side because that's the one we need more of. So you put a 2 here in front of the H2O. That changes the number of H's though. So now we have 4 H's and 2 O's. And our H's are again not balanced, but our O's are okay. To fix the H's, we got to put a 2 over here in front of the H2, because that gives us 2 times 2 H's is 4. And now we have the same number of H's, 4 on both sides, and we have 2 oxygens on both sides, and that shows us a fully balanced chemical equation. So our whole actual chemical equation that shows the reaction is going to be 2H2 plus 1 O2, but we don't write that 1, yields 2H2O. All right, let's do a second practice problem. Here we have Na, which is sodium, plus water, gives us sodium hydroxide and hydrogen. So again, under the arrow, we're going to write down the elements we have. We have Na, we have O, and we have H. If you're counting on the left side, it looks like we have 1 Na, 1 O, and 2 H's. And on the right side, we have 1 Na, 1 O, and we have 1 H from the NaOH, plus 2 from over here, so that gives us a total of 3. So the first thing we see unbalanced is the H's. So if we put a 2 here in front of H2O, that changes the H's to 4 and the O's to 2. And then you could change the 2 here, or you change the NaOH coefficient to 2, which would fix our O's now that they're messed up, but it also messes up our NA's. That's okay, because we can fix the NA's pretty quickly by putting a 2 over here in front of that Na, and now we're good to go. All right, last but not least, very easy one, we have zinc plus hydrochloric acid yields zinc chloride plus hydrogen. Again, under the arrow, we're going to write down what we have. We have zinc, hydrogen, and chlorine. On the left side, we have 1 zinc, 1 hydrogen, and 1 chlorine. On the right side, we have 1 zinc, 2 hydrogens, and 2 chlorines. We need more H's and Cl's on the left side, and there's a very easy way to do that because we have an HCl. So if we just put a 2 there in front of the HCl, that gives us 2 here, and now we're all completely balanced.